Welcome to Chapter 7, Binomial Model. So basically we will talk about the binomial model, which was introduced by Cox, Ross, Rubinstein in 1979. So this is actually after the Black-Scholes model has been published in the literature. And you can think of binomial model as the discrete version of the Black-Scholes model. And in the binomial model, we can price different types of options, including the American options, which we cannot get analytical or exact solution in the Black-Scholes model. So here is the Black-Scholes model, just a brief review. The dynamics of the stock prices is given in equation 1. And you can notice that we have the noise term that's generated from a Wiener process or Brownian motion process. And basically, we have the drift term, mu. So when we see the mu, that means this is actually with respect to the physical measure here. So we are actually in the physical probability measure because we still have this mu. But in the Black-Scholes model, when we switch to the risk-neutral world, and use a risk-neutral probability measure, then you can notice that we will have just the risk-free rate R. So this is with respect to the risk-neutral measure, actually. Okay, so I'm not going to get into the stochastic calculus details here, how to do the change or measure things. That's not our main focus here. But basically, we can obtain the solution of equation 2 by the use of Ito calculus, of course, and that's given that gives us the stock price ST in terms of the S0 times the exponential of this Brownian motion expression. And we can also actually write these stock prices in a step-by-step manner using delta t time steps. So we can see that we have a fixed time step delta t, and this time we have just delta wt. So each increment is generated from basically the noise coming from this term, but notice that by the defining properties of Brownian motion, actually delta wt is going to have a normal distribution with mean 0, and the variance is going to be delta t. And that's also already given here. And basically, in the binomial model, we will need to know the first two moments of the basically stock prices given the previous time step. Okay, so the first moment is the conditional expectation of ST given the previous time step value of the stock prices ST minus 1. And we know this basically, this is coming due to the fact that this ST is a log normal random variable, right? Because you can see that we have a normal random variable in the exponential. Therefore, if you exponentiate a normal random variable with some extra drift term here, which doesn't change the result, you will get this ST as a log normal, okay? And by from statistics knowledge, we know what's the mean and what's the variance of a log normal random variable, okay? And you can easily check that on the internet as well. So basically, we can calculate this conditional expectation, which is given here, and the second moment, which is the variance conditioned on the previous value of the stock price. So this is also given from the basically log normality property here. Okay. So let's move on. So in the binomial model, we will first explain what happens in one time step, and then this can be generalized to n number of time steps. So you can see that we have these delta t time steps, and the initial stock price is S0. So there are two states of the nature in our binomial model. The stock prices can either go up or they can go down. So this is down and up. And basically these are denoted with these possible realizations. For example, in, of course, 2 time steps, then you have 4 possibilities. So this is just like you can have you can flip the coin twice, and you can have head, 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 tail, tail, head, or tail, tail as 4 possible outcomes when you flip the coin twice. So that's the 2 time steps scenario. So basically, our goal is to come up with, again, similar branch, similar binomial tree for the value of the financial derivative f. So here f represents the value of the financial derivative, and this is at time step 0, and this is at time step 1. Again, based on what happens to the stock prices, the value of the financial derivative will follow this two possible states of the nature. Okay, and next our goal is going to be basically to create a so-called replicating portfolio. So we are interested to find this portfolio. So this is our so-called replicating portfolio. And our goal is to create a portfolio such that in both states of the nature, the value of the financial derivative equals to the value of this portfolio. So by the no arbitrage arguments, we will say that if the time 1 value of the portfolio matches the value of the financial derivative, then time 0 value of the portfolio must also be equal to the time 0 value of the financial derivative. So this is going to be our no arbitrage argument, and by using this argument we can come up with the price. Okay, so you can notice that if the stock price goes up, you have phi number of stocks, so the value of your stock holding is phi times S1H. And if the stock price goes down, which is the second state of the nature, your stock holding value is going to be phi times S1T. And whatever remains, you are depositing in the bank, so which is going to be independent from the state of the nature, because this is just going to grow proportional to the risk-free rate. So next we will derive using these two equations and two unknowns, which is phi and psi. We will solve this equation.